Hello viewers, welcome back to our YouTube channel, and today we want to continue with our series of quantitative techniques, CPA level 1 paper. And today we want to look at the histogram. Histogram as a mode of presentation of data, and of course this is one of the examinable numbers, of course frequently examinable numbers. Of course a histogram is just this is a graphical representation of a grouped frequency, distribution, a graphical representation of a grouped frequency distribution of a data set, So it is a graph that has both the y-axis and then the x-axis, but these graphs they include what we call vertical bars, and these vertical bars, the only identification or the only differentiating feature with a histogram and that of a bar chart is that this one has no space. So here we have no space. We have what you call vertical bars with no space. In between. Them. So we have vertical bars, but within these vertical bars we don't have any space in between the bars. So it is a graph including vertical bars without space between those vertical bars. So the class intervals, sometimes they may call them class boundaries, are the ones that we plot along the horizontal axis, and then their respective class frequencies are plotted on the vertical axis using a suitable scale for each axis. Now, for each class, we are going to draw a bar, and that bar has a width, or its base will be the class, and then the height of that bar will be its respective class frequency. So it is just a vertical bar, but the width of that, or the base as the width of the bar, will be represented, or will be representing a class. Then the height of that bar will be representing the class frequency of that value that you are talking about. So when we talk about the histogram we've looked at it as a fact that we are looking at the grouped frequency distribution of the data set. Now, the one that is going to represent the grouped frequency distribution, we call it group T. It's a frequency histogram, grouped frequency histogram. Now, the reason why we call it a frequency histogram is because this bar graph that we draw, it represents the frequency distribution of the data set. That's why we call it frequency distribution, because it is going to be portraying the different frequencies of each of the individual data set as may be given to us. So the histogram displays the data by using contiguous vertical bars. Now there are situations someone is going to assume that now what if I have a frequency 0? What will happen? Because we are saying these are bars and each bar has a base. The base as the width will be representing the class. Now, what if this bar has no frequencies, like the frequency is 0? Now, when the frequency is 0, we are not going to have those vertical bars, because we've said that the bar is going to be representing the heights. The height of that bar is going to be a representation of the class frequency, or the frequencies of the different classes. So if the class is 0, if the class has a 0 frequency, it means it will not have any bar. So a histogram, of course, we always put quantitative values. It's going to be representing the quantitative data. But most of the times we will find that we have a class. We have gotten a class, and these classes most of the times they are more in the qualitative data. But remember, these classes, they may give you a class maybe of, let's say, they give you a class of, let's say, 40 to 50, or 40 to 49. Now you will see that these classes, the different classes we are going to have of the quantitative data are going to be in the place of the distinct values of the qualitative data. So you'll find that most of the textbooks, you may find that even the statistical softwares, you'll find those applications are using maybe frequencies, or they are using relative frequencies, or they are using percentages as the labels that they have used to label the histogram. Now, of course, we need to understand that the histogram has properties, and one of the properties is that the horizontal scale is quantitative, and it measures the data values, the horizontal scale. Horizontal scale is quantitative. Quantitative, and it measures the data values. Number two, of course, the vertical scale. What we have with the vertical scale is that the vertical scale measures the frequencies of the different classes. This one measures the frequencies of the different classes. Then the other most important property is that the consecutive bars must touch each other. In other words, we are going to have bars that are close to each other. They are intact. We don't have spaces. And because of the fact that we have what you call consecutive bars of or that are going to be representing our data set, we are going to find ourselves that these bars must begin and then end at the class boundaries instead of the class limits. I've told you the third property is consecutive bars must touch. In other words, they must touch each other. And what is going to come out of this is the fact that if I'm drawing these bars and you find that these bars are actually supposed to touch each other like that, the implication is that when I'm labeling my vertical axis, I'm going to use class boundaries and not class limits. Remember we said if you want to get the class limit, if you are given a class of, let's say, 40 to 49, these are class limits. This is the lower limit, 40 is the lower class limit, then 49 is the upper class limit. But now if I want to get the class boundary, I subtract 0.5 from 40, then I add 0.5 49. So it will be a 4, when I subtract, it's 40 minus 0.5, that will give you a 39.5. 39.5, then when I add 49 plus 0.5, I will be getting 49.5. So we are going to be using these class boundaries. This is the upper class boundary, this is the lower. This is the lower class boundary, this is the upper class boundary. Now, the reason as why we are using these class boundary is the fact that class boundaries gives us those numbers that separate classes without forming gaps between those different classes. So we are using class boundaries because it is these class boundaries that are going to remove the spaces that we have been using under the bar chart. So we remove the classes. And the other thing that we do, we make sure that when we are drawing, we have a kink. It's like we make some zigzag here from the start. We can draw a zigzag line here from the start here we are going to be having a 0, but we draw a zigzag, then we start. The reason as why we are putting this zigzag line or a kink is because we want to make sure that we show that this data is not actually starting from 0. We are starting to plot this graph from somewhere at a distance far, maybe at a certain distance far from the 0. So, but of course, there are those that you may find maybe for the ungrouped frequency distributions. For the ungrouped frequency distributions, of course, we use the distinct values of the observations to label the bars. Remember, for the ungrouped, they give you values that are not in classes. They may give you 10. So we use these digits, 10, 20, 30, like that. So we use those digits or those distinctive values of the observations to label the bars. And of course, with each of these values is going to be centered under its bar. But as I told you, as per the examination purposes, they always bring the histogram for grouped frequency distribution. And for the grouped frequency distribution, we use the lower class boundaries and then the upper class boundaries. So, but basically we take the lower class boundaries of each of those classes to represent the bars. Instead of taking the upper, we always pick the lower class boundaries of each of the class to represent the lower class limits. So those are the ones that we use to label the bars. But of course, as I told you, from the different maybe statisticians and some technologies like the softwares, statistical softwares, most of the times they use the class marks, or what we call the class midpoints. And of course, these class midpoints, they always center them under the bars. So a histogram, of course, a histogram that uses frequencies on the vertical axis, we call it a frequency histogram. And of course, the one that uses either relative frequency, because we told you that they may use relative frequency or they may use even percentages. So if they are using relative frequency or percentages on the vertical axis, then they are going to be called relative frequency or percentage histogram, respectively, depending on what they have given to you in the question. So I was just creating or shading a picture for you to understand deeper, but we want to look at now the steps, having understood the theoretical, some of the basic theoretical things that we can talk about as far as the histogram is concerned. I want us to look at the steps on how we can be able to draw a histogram. So let's look at the steps. Steps for constructing a histogram. So let's start with the first step. The first step is for us to obtain the frequency. To obtain we can call it a frequency distribution. It could be frequency or it could be relative frequency. Okay, let me just put frequency stroke relative frequency because it might be relative frequency stroke percentage distribution, because I may give you only frequency and the of the data. So whatever they have told you, if they have called it relative frequency distribution, or they have called it maybe percentage histogram, then you will be able to know what you are going to draw. That's the first step. The second step is for us to draw a horizontal. We draw a horizontal axis, of course, on which to place the bars, and of course the vertical axis and the vertical axis on which to display the frequencies. They are either frequencies or relative frequencies or percentage frequencies. So it depends on what they have given to you in the question. And of course we draw these lines. They are perpendicular lines, and then we label the vertical and the horizontal axis. We said that on the vertical we always put frequencies, then on the horizontal or on the vertical we put the frequencies, on the horizontal we put the class boundary, but we've said specifically they are going to be lower class boundary of each of the classes. So we draw the vertical axis, and we say the vertical axis on which to display the frequencies. They could be frequencies, they could be relative frequencies, or they could be percentages. Then the third one is for us to, of course, for each class, we construct a vertical bar. A vertical bar whose height equals the frequency. And we said it could be equaling to the frequency, it could be relative frequency, or it could be percentage or percent of that class. And of course, lastly, number 4, we said we label the bars. We label the bars with the classes the horizontal axis with the name of the variable and then the vertical axis with frequencies we can call them relative frequencies or percentage or percentages, depending on what they have told you. So the vertical scale, they will always give you the data, but this data they have given to you, it could be, they may give you classes as a variable, they may give you age, they may give you scores. So whatever they have given to you as a variable, they could be heights, they could be ages. That's what you name the horizontal scale. Then of course the vertical scale is going to be the one that is representing the frequency or the relative frequency or the percentage or the percent. So we need to look at a simulation and then we'll be able to solve it out. So let's use maybe a basic one where we are not providing simulation, we are not providing tallying of the information. Let's get, maybe we get the value that is already grouped and we don't go through the other process of tallying. So example, let's say that the weights of 65 children are given below, are given by the following table, Of course we have the weights, then we have the frequencies, So they have given us a class of 50 to 60. Then they have given us 60 to 70. They have also given us a class of 70 to 80. We have a class of 80 to 90. And of course, the class goes up to the last class. This one you put other classes. Maybe let me just stop at this class, 90 to 100. Let me stop there. But in the question, we are stopping at up to a class of 120. Then of course this one is 8. They are saying 10, 16, 14, and then 10. Of course we go to the required. The required says draw a histogram to represent the data. So we get the solution. Of course, if you look at this information that is given to us in the question, we are seeing that it has a class of 50 to 60. And I told you we need to get the class boundaries. Remember, I told you that we look at the class. Is it an inclusive class or an exclusive class? Basing from what we had discussed, we had looked at the inclusive class, whereby we had gaps. But if you look at this data set is not an inclusive class, it's an exclusive class. So once we have exclusive classes, the implication is that what we have been given to us in the question are the class boundaries, because we don't have any gap between the classes. The reason why we get class boundaries is for us to be able to remove that gap that exists between two classes, because you are seeing this is 50 to 60, then 60 to 70, meaning the 50 to 60, that 60 is not included in that class, it is in the next class. That is the implication. So I wanted to make sure that I give you aspects that relates to both classes, because when we were discussing, we discussed a question that required us to get class boundaries, but we found that the question that was given to us, what was given to us was the class boundaries. The class limits are the same as the class boundaries. So I wanted us to have that idea and be able to appreciate the fact that when you are being given such a class, you don't need to compute the class boundaries, because the class limits are going to be the same as the class boundaries. Of course, if you look at the frequencies, you can go ahead to compute the percentage, or you compute the relative frequency if you want, but frequencies are better. You can just go with what has been given to you to save time, especially in an exam. So what we find out, we have to get the vertical scale for all these frequencies. Of course, to get the vertical scale, we said we look at the minimum value and then the maximum value, so that we can be able to compare and contrast to see how we can set our vertical scale to represent our frequency histogram, depending on the number of observations that they have given to us. So for this, you can see that the highest frequency is 16, and then the smallest is 8. So what are we going to do to our scale? We can say maybe we can, because we can easily get to we can easily get to 16. So we can maybe say 2 centimeters. We can just use 1 centimeter to represent maybe 2 units, such that 1 small square is equivalent to 2/5. And of course, we know that 2 over 5 is actually a 0.4, 0.4, meaning one small square is 0.4 unit or units. Now for the horizontal scale, because we have very few classes, you can as well, you can say maybe 2 centimeter, because we are not going to leave spaces. You can say 2 centimeters to represent one class. But since these were given, whatever that was given to us, the vertical, in this case, the vertical scale is the one that matters. The horizontal scale, you can use any. Of course, we can draw our, just me, I'm showing a sketch for you to be able to draw a very organized chart. So we start from 0. Remember the laws of drawing graphs. Start from 0. Then we indicate our values. From here, you can choose to indicate maybe 2. For me, I'm just going to put random figures. Let me put 8. Let me put 10 here. Let me put 12 here. Let me put 16 up here on the top. And of course, this side, let me start maybe from here. And we have only 5. So that one, maybe that one, that one, that one, maybe up to that point. So now we are picking, but remember we said we pick class. Now, from our question, we've seen that it's 50 to 60, 60 to 70, like that, until we reached 100. So what that means is that on the horizontal scale, we are going to name the horizontal scale as weights, because these were weights that were given to us, and we had a 50 to 70. So we start with a 50, a 60, 70, 80, 90, up to 100. So you've seen that I only taken out the lower class boundary of each of the classes. In other words, I've picked the lower class limit from that class, because we said the class limits are going to be the same as the, if you look at this information, I only picked out this 50, this 60, this 70, then this 80, and then this 90 from each of the classes. So in some, of course, let's maybe first put these values maybe in vertical columns. That's when maybe you'll understand more. Let's try to put these values in a vertical column. We have a 50 to 60, a 60 to 70, then 70 to 80, 80 to 90, then 90, 90 to 100. Now we have just, if you draw a line like that, we have taken these values. The reason why we include this 100 is because this 100 in the next class, it's going to be the lower value. And the reason why the other reason as to why we are taking this 100 is for the fact that we don't want to have gaps. So someone is going to ask, what if we are taking only these ones? These ones. Why are we including 100? We are eliminating the gaps. This 100 in the next class, it will be 100, 100 to 110. So you just draw like this, as if you are drawing a 7. Then you take these values outside. But taking these values outside doesn't necessarily mean that we are taking the upper class boundary. No, we are taking the lower class boundary, because I've said we are including this 50, and we are also including this 100. The reason why we are taking this 100 is because this 100 is going to be the lower class boundary of the next class, and we wanted to create that intactness, that these graphs, these bars are not going to have spaces. That's why we take it that way, but it doesn't mean that we are taking the upper class boundary. Get me right? Because if you look at it, if you look at these values, of course these are the upper, but they are not the ones we are taking. We take these, and we have included this 100 just to show that the next class, this number is inclusive. It's like we have picked the next class. That's what I wanted to highlight. So let's draw our chart. Of course, I told you here we start with a zigzag, or what we call a kink from here. The reason is very simple, because there are other values. Remember, we are starting from 0, but there are other values that we are not plotting, but we are only plotting from 50. That's why we put that kink, to show that the break that we have put there shows that the graph is continuous. If at all, it's only that it doesn't include the data set that is below 50. That is the only implication as to why we put that kink. So then we draw. You just represent it with the frequency, without getting a summation. So 50 to 60 is having 8. So we move 8 is around here. Then the other one is 10. The next one is 16. The other one is 10. Then lastly is 5. Let's assume 5 is around there. And you are done. Of course, let me first make this one straight. Of course, you'll find that after drawing this, they will tell you to find the model mark or the model class. But if they tell you to get the model mark, you just connect. You pick out the highest bar, then you draw a diagonal line connecting to the next corner here. Then you also connect here to that one. And then where these two lines meet, of course, you read the value that is here. This would be our model mark, the value there. Of course, you will see that from this point, you have a 70, so it will be 70 plus. Then you interpret your scale from here up to here. How many small squares are there? Remember, we said that this is going to have maybe 1. Let's assume maybe we had 2. Then it will be 2 times what you have interpreted from the small squares. If they are 0.5 units, then you multiply and you find that it will be 70 plus a 1, that will give you a 71, which will be our model weight. So you read the point in here. So that's all to do with the histogram. Of course, you put a title as a histogram showing the weights. Then maybe we can just a small to just create an illustration of the inclusive classes, because this was basically for exclusive classes. And when we are discussing, we talked about the inclusive classes. So let's also look at how it can be illustrated. Then we see what we can have. Just have an illustration. Example 2. Example 2, we have the following, the data below. The data below shows the scores of 31 students in a test. Then we can indicate the data set. We have the classes and then the frequency. We have a class of 40 to 49. We also have a class from 50 to 59. We have a class of 60 to 69. We also have a class of 70 to 79. And then finally we have 80 to 89. So we show the frequencies. The frequency, this one is 4, this one is 7, this one is 11, this is 6, and this is 3. So let's look at the required. They are telling us to draw a histogram to represent the data. So the required says, the required draw a histogram to represent the data. So let's have our solution. And as I told you, one thing we start with, we start by getting the class boundaries, because this is an inclusive classes. Classes were 40, 49, 50 to 59, then 60 to 69, 70 to 79, and then finally 80 to 89. We get the frequencies, we write them the way they are. This was 4, this is 7, this is 11, this is 6, and this is 3. Now we get the class boundaries. So we've said for you to get the class boundaries, you first get the 40 minus 0.5. That gives you 39.5. You get the class limit, which is 40 minus 0.5, for you to get the lower class boundary. So this 39.5 will be here, 2. Then for us to get the upper class boundary of that same class, it is 49 plus 0.5. That gives you 49.5. So here it will be 49.5. Even here we do the same thing, but remember what I told you, that you can first get these values. You can first get the ones, the upper. This is, of course, 59 plus, this will be 59.5. This, actually, the other option, you can add the class interval. What is the class interval? From 40 to 49, there are 10, because you include even the 40. You count 40, 41, 42, 43, 44, 45, 46, 49. Those are 10. So you get 49.5 plus 10. That will give you 59.5. So you keep on adding 10. So this will be 69.5. This will be 79.5. Even this one will be 89.5. So there are very many tricks, but don't use these tricks if you don't understand it. First, take it from the basic point of view. Then we said we just transfer this value. This one, we take it this side. This one, and this one. That's what we said we do. So we take those values. So this is 49.5. This is 59.5. This is 69.5. This is 79.5. Because we are trying to remove the points. But now when we are drawing the curve, we take these values here, the ones on our left hand side. But I told you, we don't take them and we say, just in short, I'm just giving you a shortcut for you. Just draw something like 7 like this. Then you take these values that are outside, including this one. But that doesn't mean that we are taking the upper class boundaries. We take the lower class boundary. And this one, the 89.5, we take it in a sense that it will be an upper, it will be a lower class boundary in the next class, and that's why we take it. So I hope you are getting the picture. So these are the ones that we are going to take to label our chart. So you just draw this, as I told you, something like a 7 from the first class until you finish all the classes, and then we go with that. We go with these values here, but we said we take them because they are, all of them are lower class. If you look at this, 49 is a lower class in this. If you look at 59, it's a lower class here. So those are the ones we put at this, they are the ones that we plot against the frequencies. So we are going to plot this and this, not this, because we can't plot this. So it means that here you are going to get a scale for both. Remember, even the horizontal axis has values. This is 39.5 up to 89.5. So you need to get a suitable scale. For, if you look at the frequency, the highest frequency is 11. It means you just take 1 centimeter to represent 1 unit. Because you will be in a graph, I'm very sure you have those 10 centimeters that can represent the 11. The highest value as 11. But it is the same thing, we put a kink. In other words, we don't start from the vertical line. So we said we get the scale, and of course we say the vertical scale is going to be 1 centimeter to represent 1 unit for you who are using the graph book. Then the horizontal scale, this one, the horizontal scale is also very important because we need to interpret our scale. We can say 2 centimeters because we are moving up from 39.5 to 89.5. One of the best ways for you to get a scale is you just get the range and then you divide how many squares are on the horizontal. If you count, maybe you want to use 10, maybe you can count the centimeters. You may say, I'm going to use 2 centimeters. Then you count how many 2 centimeters are available on the horizontal scale. Then you divide with that number. If they are 10, you say maybe you get the other range, you divide by 10, then you round off to be able to get a suitable scale. But most of the times you use that if you are not sure, if you don't know what you're doing. But the moment you know, the moment you keep practicing, you will find it easy for you to determine the scale, even when you don't do those kind of mathematics that takes time. So for this one, we can say maybe let each represent 20 units. So you interpret, maybe, of course, this will be it means 1 small square will be equivalent to 2 units. Then you go ahead to draw the bars. So let's draw our axes. I'm just going to name, this is 2, this is maybe 6, this is maybe 10, this is 12. I'm just naming, but for you, you follow your, but here we start from 0. It is very important because we looked at the properties of drawing bars, and we said we always put 0. And that is same 0 that we put there is one of the reasons as to why we put a kink. It's one of the reasons as why we put a kink at the start, because the moment you plot your graph from here, it means you are plotting even values that are starting from 0 to this value here. yet it's not. The only values that we are plotting, they are values that are coming. We put a kink here to show that they are values that are coming there but are not part of what we are plotting. Given the fact that here we have a 0. So you be very careful when you are drawing some of these. Of course, some textbooks you may find when they are not following some of these things. It's okay. We don't say you are supposed to draw things that are going to be perfect in nature. But at least there are some standards that we follow, because we know that we are not going to use the same scale, we are not going to use, but at least there are things that we are sure. We always put a kink, or that is zigzag line, to show that there are values that are coming first, then we are only plotting what has been given to us. So here we start with 39.5. Then this is 49.5. We make sure that each slash we put here represents a class. This is 59.5. Then this is 69.5. Then this is 79.5. And then 89.5. Then we start our bars. We've seen that this one had a 4, so let's assume the 4 is around there. Then the next one was 7. Let's assume 7 is around there. To make sure the bars are the same, that's why we provide a scale to make sure the bars are the same. Because within these values here, we have the same interval, class interval 10. So the next one is 11. Let's assume the 11 is around there. The next one is 6. Then lastly is a 3. And we will be done. That's it. If they want you to get the mod, of course you just connect these corners here. Then even this corner, you connect, you take the highest, you pick out the highest bar, then you connect. So don't expect me to talk about how we find the mod using this. Just know this is how we get it. You draw a line moving downwards, then you start interpreting your graph. So we are starting from this. It is a 59.5 plus what is from here to here. Maybe if they are small squares, maybe they are 5, you take 5. How many? Each square is what? Maybe it is representing 0.5. Then you multiply, and then you get the answer. So that's how we draw the histogram to represent the data set that we have been given in the question. So the next one we are going to look at is a frequency polygon. It's also a little bit similar to do with the histogram, but the other side we shall see that the differentiating feature is that for it we only take the midpoint. So that's all for today. Let's meet in the next video as we are talking about the frequency polygon. But the other thing is that if you want to join our classes, CPA all recorded video lectures about CPA for all the course units, just reach out to our WhatsApp. We always put the WhatsApp number. You can call, you can just text, and then we can be able to add you to our recorded classes, and you gain full access for a full year, 12 months from the time of payment. We only charge 200,000 Ugandan shillings. That's not even, it's around 50 US dollars. So that's it for today.